Example 5 asks us to look at a diagram and based upon the values in the diagram, find the exact lengths of different sides of different triangles. Well, what we're studying right now is the ratios of sides of triangles. That's what trigonometry is all about. So we want to use our trig forms to help figure out and help set up equations for us to find those sides. So if we first consider um, our large triangle here, we see that we have an angle of 30 degrees, and because it's also a right triangle, and we have a hypotenuse of 8. So we need something that relates the opposite side of a right triangle, of an angle, to its hypotenuse. And that's going to be the sine function. So we can say, hey, the sine of 30 degrees equals the opposite side. So I'm going to call that x over 8. Okay? Well, if we wanted to solve for x, we would want to multiply the 8 over to the other side, and it would create x equals 8 sine theta. Or excuse me, sine 30. So before we would take this and put it into our calculator. But what we want to do now is actually use the unit circle and use the exact value to figure this out. So no calculator necessary. Well, the sine of 30, if we think about our unit circle, is 1/2. And so in this case, we would have x to be 4, or the side AC to equal 4. Oops. So we set it up just like before, but now we're using exact value. Now it wants AD. Okay. Well, AD, how do we find that? Well, that is actually the hypotenuse of the smaller triangle. And now that we know that this side is 4, we can make an assumption here. We can say, hey, again, the sine of 45 equals 4 over x, the thing that we're looking for. So we're looking for this side. So now we want to solve for x on this side, which is going to be, again, AD. Now, what we're going to do is, just like the last problem, if we multiply this over, we're going to have x times the sine of 45 degrees equals 4. And we're going to divide this over. So in a sense, what we're doing in this type of format is we can actually switch the denominator with the other side's numerator. So we're going to get the sine of 45 degrees equals 4. No, excuse me. I'm losing my mind. We're going to get x equals 4 over this sine of 45. Well, what's the sine of 45 degrees? If you remember from our unit circle, it's the square root of 2 over 2. So we get 4 divided by the square root of 2 over 2. Which, if we want to simplify this a little bit more, what we can think about is this is the same thing as 4 times the denominator flipped upside down, right? Division is the reciprocal of multiplication. So if we're dividing by something, we can multiply by its reciprocal and get the same value. And this is going to be 8 over the square root of 2, which, if we were to rationalize this, we multiply by the square root of 2 on top and bottom, and we would get 8 square root of 2 over 2, which is 4 times the square root of 2. So because we had that square root in there, it added quite a few steps. But you're not always going to have that with trig problems. But we know that that is going to be AD now. Now the last part says we want BD, so we want this side only. Well, what we know again is that we can assume, because this is a 45, 90, 45 triangle, we can assume here that that side right here is going to be 4, because we know that that's 4. So if we're looking for this part here, we can relate the two of them together and find this out. So follow me here. And I'm going to do some of this problem on the next page. But we're looking, we know that this is 4. We know that this is 4. We're going to call that x. So we have our 30-degree angle. So what relates the opposite side to the adjacent side? Well, that's going to be our tangent function. Now, we could use a lot of different functions here if we want, but that would help us with this particular problem. So I'm going to say, hey, the tangent, or well, the tangent of 30, which we could do tangent. We could also do cosine. Cosine could also work very easily. We'll do cosine. Cosine of 30 degrees, and the reason why I'm saying that is because we haven't gotten too familiar with tangent yet to kind of get that from the unit circle, but you could certainly do it. The tangent of 30 degrees is just the square root of 3 over 3. But cosine of 30 degrees would be the same thing as our 4 plus our x, or x plus 4 over 8. So we would have x plus 4 equals 8 times the cosine of 30. And now I'm going to move this to the bottom part. And so from here, we can replace the cosine of 30, which is the square root of 3 over 2. Now this one works out pretty well, because 8 times the square root of 3 over 2, we can just link those together. And 8 over 2 is the same thing as 4, so we're going to get x equals, or excuse me, x plus 4 equals 4 square root of 3. And so we get x to be 4 square root of 3 minus 4. So that's the same thing as our BD. So these problems can be quick or a little more complex, but we want to think about how can we use a trig function and its true value to find these other sides. And remember, square roots are okay to have in the problem. We just don't want them in our denominator like in the second part of this problem.